This is a tutorial video of a MATLAB script based around the NAE Grand Challenge on how to make solar power more economical. Solar energy provides less than 1% of the world's total energy, but it has the potential to provide much, much more. As a source of energy, nothing matches the sun. It outpowers anything that human technology could ever produce. Only a small fraction of the sun's output power strikes the earth, but even that provides 10,000 times as much as all the commercial energy that humans use on the planet. Why is solar energy important? Already, the sun's contribution to the human energy needs is substantial. Worldwide, solar electricity generation is a growing, multi-billion-dollar industry. But solar's share of the total energy market remains rather small, well below 1% of total energy consumption, compared with roughly 85% from oil, natural gas, and coal. Those fossil fuels cannot remain the dominant sources of energy forever. Whatever the precise timetable for their depletion, oil and gas supplies will not keep up with growing energy demands. Coal is available in abundance, but its use exacerbates air and water pollution problems. And coal contributes even more substantially than the other fossil fuels to the buildup of carbon dioxide in the atmosphere. For a long-term, sustainable energy source, solar power offers an attractive alternative. Its availability far exceeds any conceivable future energy demands. It is environmentally clean, and its energy transmitted from the sun to the earth free of charge. Now that being said, we can move on to our algorithm sheet for this particular MATLAB code. So we've been asked to create a MATLAB code with the data we found in the previous NAE assignment, which would be this Excel table right here, showing the years and power outputs. So we asked the user what he would like to know: the max overall power output by year, the max power output by cell type, and max power output per dollar, and minimum cost for this range of years. The program will then retrieve the values the user asked for, and if the user would like to know anything else, and it will continue to ask the questions until the user says no. Going down here to the algorithm, first, the knowns are what the user wants to know, so whatever they put in. And then if they want to know anything else, or rather if the program should repeat itself or not, then the unknown would be the actual values. So the algorithm is pretty simple. Basic housekeeping commands. First, it loads the file with the datasheet. This file can be changed, can be updated, can change in size, as long as only new years and the corresponding data is added to the table. Then a while loop to restart the program. The whole code is encompassed by a while loop that will restart the program if the user desires to do so. Then it asks what the user would like to know and gives options. Then the user clicks on those options and the code will retrieve the results, and it will ask the user again if they want to know something else, and it will keep going until the user says no. Here are the test cases, the possible outputs and inputs, and we'll look into that later. So here we have the actual script. Up top we can see the basic housekeeping commands, and then where we load the actual data. And then there's a defined variable here, so the code will actually run for the while loop. That will depend on the menu option at the very bottom here. Now within this while loop lies the entire code basically, and it starts off with a menu option, and it asks basically what the user would like to know. Now there's 4 options here, and if the user picks the first choice, it'll go to this if statement right here that will go and run these 4 loops over here and retrieve the data that the user is asking for. And as you can see, there's variables used here, so that means the code is fairly flexible, and it can handle a different size of a matrix as long as the matrix makes sense for the scripts, as long as it's years and the numbers entered are consistent with what the matrix is about. Then if it's not the first choice, it will go to the second one, which again it's an if statement that will run some for loops, making it flexible, f(printf) at the end, and so forth to the third one. Same thing, for loops. And the fourth option, choice 4, same thing. And then right here at the end of everything, there's a selection menu if they would like to know anything else, and if they say yes, then the code will repeat itself, and if the user says no, the code will stop. Now let's go ahead and run it. Right here pops up that menu. What would you like to know? Let's go with our first option, max overall power output by year. Immediately it asks if we want to know something else. Let's go here, and it gives you the value from the table, the year in, and the power. Now, would we like to know something else? Yes. Now let's go with the second option here, max power output by cell type. And it says right here the type of cell that produces the maximum overall power was the crystalline silicon cell, which out of the table that we had was one of 2, and so that would make sense when you look at the numbers. So let's see something else here. The minimum for the range of years, and you see it retrieves the minimum cost per cell occurs in 2009, and it's $1.27. All of these numbers have been retrieved from this table. As you can see, 2009, $1.27, the 2 types of cells, and the power right here. And then finally, the last option for this code, the max power per cost. And that would be as many kilowatts per dollars, and that would be in the crystalline silicon cell in the year 2009. Alright. Would we like to know something else? No, that was everything for now. Now, obviously this code is very simple in the sense that it only serves as a data retrieving software, if you will. It's limited to pretty much the setup which it's in. It's limited to those 4 questions, and it's limited to a data table that would actually that would have to have these 4 things. It would have to have the year on this side, the 2 cell types and their powers in the middle, and then the dollar amount at the very last column. Now this can be as big as you want, and it will still work, but adding another column would limit the effectiveness, would limit this code. It would make it so that it might not run or might not make sense. So, but we don't really care about that. We care about retrieving these data sets on solar power and the cells. Engineers might use this to compare their progress from year to year, see how the advance is going. And with that in mind, that was the tutorial video for this particular MATLAB script. Thank you for watching and have a good day.